Hey, Vlad here from DependencyGraph.com. Welcome to the next video in the ZLayer series. In the previous video, we not only learned about has, but also started hiding it. Today, we're going to finish hiding it by learning about ZLayers and also learn about effect tracking. As you might have noticed, we're still not done with the reader channel, and as already mentioned many times, you don't have to use it, but if you want your ZL code to be idiomatic, you have to keep learning about it. So let's get right to it. All right, so this is exactly where we left off, and a couple of videos ago I mentioned that we're totally divergent from the path of assembling our application properly so that I can just mess around in the main and show you a couple of things. Today we're going to go back to assembling everything properly and have our proper layers, not even ZLayers, just like the regular layers of our application. This way we will be forced to deal with this pesky has that is leaking out of our ZO. So we already have our console somewhere, right, which kind of looks all right. It already has a trait, it already has, an implementation. We also have the business logic, which, is also already has a trait and it has, the implementation. So now we're going to bring Google up to speed. First, let me throw out this old example. We actually don't need it anymore. So we have the business logic, and I'm going to go underneath. So we have the Google and we have the Google implementation. So we're going to surround it with our object, the same as we have been doing it before with the others, right? So we're going to do object Google, right? Inside of it, we're going to have type Google, and it's going to have the Google.service, which is going to be this service, right? So we need to indent it more to the right. So now we're going to have object Google over here like this, indent it more to the right like this. All right. And so now we're going to need this helper method, right? So we're going to have this thing, right? So it's going to look like, well, I can pretty much copy the whole thing. And the only difference is that over here, it's going to use Google, right? And now it's going to do zio.access underscore get count pictures of and topic. Okay, I'm not going to save the file just yet. I would like to remind you about the fact that the Google implementation usually would live in its own separate submodule, but I wanted to have the ability to use this import to switch between the real ZO and our application, and so I ended up throwing everything into the same file. Okay, so we have the Google implementation separately. Okay, so let's go and improve it a little bit. So now it's going to be over here. It's going to do Google.service, and this is going to change later as well. Same deal over here, Google.service like this, and the rest can pretty much stay the same. Before I save the file, let's also go and fix the usage side. Okay, so this is the business logic. So it has a Google over here, so it should probably have Google.service, and we're going to change it later. Once we finish hiding has, we're not going to see like any of this service stuff flying around. Okay, so we're going to go over here. And let's probably switch this thing to G, and we're going to do Google.service like this. Notice that just a second ago we created a similar delegation method like this one, but inside of Google, but we're not using it anywhere. Okay, it's going to become very, very important by the end of the video. And by the way, this video might end up really, really long, and I might split it into 2 or maybe even in 3. And by the way, since we're on YouTube, guys, don't forget to hit the like button. It really helps out the algorithm. Let me actually try to save the file because I believe at this point this is already everything that we need. Yeah, everything still works. Cool. So let's finally go back to assembling the proper application. Now, every application, and I'm actually planning to make videos about architecture right after this ZO series. Every application should have at least 4 layers. The first layer is the business logic. We already have that. The second layer is the stuff that the business logic needs. This is Google. We already have that. Then we need a way to deliver our applications. I usually call this part controller. This is basically anything that uses the business logic, and we don't have that yet. And then you have the main, in which you basically have the dependency injection, where you select all the parts and clip them together. Now, since this is a very tiny application, and you remember I really wanted to have the ability to mix stuff in the main method, we kind of mixed the controller in the main method, right? Like this should be in the controller. So what we're going to do now is we're going to go and introduce the controller. And by the way, guys, I really, really recommend you to build stuff from scratch. You'll learn so much. For example, we're going to start introducing the controller, and we're going to realize that the way we structured, for example, the business logic in such a way over here that it wants a Google.service is actually not the ideal way. In the controller, we're going to be forced to add 2 things, and then we're going to be like, oh, we should have been using has all along in this slot. All right, so let me go down under Google over here before we assemble the dependency graph. Okay, so over here we're going to have object controller, right? We're going to do it like the right way from the start. Okay, so it's going to be type controller. Type controller is going to be a has of controller.service. Underneath, we're going to have the object controller. Inside of it, we're going to have type service. And it is very common for services just to have like one method, right? Like usually if this was like an HTTPS or, like any HTTP API, or even like if it was like a regular terminal based application, it would have some sort of like routing mechanism over here. So you would have like only one tiny method. Okay, so this is going to be our controller. And this is a typo. This should be a trait and not a type, like this. So now we're going to have def make. All right, and it's going to need the business logic dot service, like this, and it's going to need the console dot service like this equals new colon, and then we're gonna grab this guy like this, because in Scala 3 metals cannot generate this stuff for us yet, so we can do override lazy val. It's not going to be a def run. All right, so it's going to look like this. Okay, so we can grab the implementation from the bottom, right? So we can just go over here, pretty much grab the whole for comprehension, just go up and insert it over here. Okay, like this, like that, and like that. And it's very important over here, we're going to use the C for console, and we're going to use the BL for business logic. Actually, by the end of the video, if I end up splitting it by the end of the last video, we're going to learn about a very, very cool effect tracking pattern where we're going to switch this back to using the object actually instead of these inserted things. All right, so now if we were to continue with our classical pattern, right, we would have a lazy val over here. We're going to call it live, and it's going to be ZO of business logic dot service, and then we have our issue, right, where we would need to use and, but we cannot use and because we did not start by using has. Okay, so we would need to do console dot service. Let me just finish writing it, and then nothing, and then service. Okay, and then equals, and we're going to do ZO dot from function make, okay, like this. And now that's not going to compile. So now we need to switch it to has, and we also need to go back to the other things and switch those to has as well. And I want to teach you like a common pattern to introduce these things, right? Like this is a new thing. So what we're going to do is we're going to comment it all out, right? If we were writing tasks, we would bring the state back to green, like classic TDD. Okay, right now everything is back to green. So let's go to something like Google and switch it back to has. So if we look at Google, it actually wants any, but it kind of should receive something like a has any. Now the real ZO has some built-in logic to help you out over there. I didn't bother to do it. We're just going to leave it as any, and it's going to work out, good enough. However, if you go to the business logic, okay, over here, we're going to say that over here, we don't need the Google service. We actually need Google over here, right? Over here, we still need the service, okay? So now over here, we actually need to rip out the Google service out of the Google has. Remember, this is a type alias for Google, for has google.google.service. So we need to take this thing apart a little bit like this. Okay, so by the end of this method, we're still going to call make, and we're going to call it with g, okay, right? But now we need to get the g out. Okay, so we're going to do val g equals env dot get. Now this part is going to compile. I mean, the code somewhere lower is not going to compile. What I'm saying is that it's going to compile without our specifying the type. However, once we have a combined has over here, we will end up needing to specify the type. Okay, so right away I'm going to go and specify the type. Okay, so let's go and grab the Google. Okay, and we're going to fix all of that later anyway. Okay, so this is how it's going to look like. And now in the business logic, where we're assembling the dependency graph, sorry, not in business logic, like at the point where we're assembling the dependency graph over here, we need to provide a has of g. Okay, so we're simply going to wrap it with a has, like this. Did I forget to introduce env? Yes, I did. Okay, so this now needs to be a function, right? So we're doing from function, env comes in, env then get, okay? And as I already mentioned, like over here, I can leave it out, but a bit later, we're gonna see that we cannot leave it out in the controller where we need two things, okay? So I'm gonna leave it like this for now. So now we need to go back to the controller, right, and enable it again. I hate when VS Code does this, right? Enable it again, okay, and now we can kind of like fix this pattern, okay? So we can say over here that we don't need the service, we actually need the, the combined has, like this, okay? And so now we're gonna do the same trick over here, right? So we're gonna have our environment, right? And by the end, we're gonna need to call make with BL and C, okay? So we're gonna have val BL equals and val C equals, okay, and then we're going to get it out from our environment. So you're going to do business logic dot service like this, and over here we're going to get out the console dot service. It sort of starts to feel like the the good old cake pattern, okay, like this. Let's save the file. There we go. Now again, I want to point out this like type inference weird limitation. Like somehow in Scala 3, it always can infer the first type, right? So somehow it can infer the first type, but it cannot infer the second type. It's kind of weird. I don't know, like it's a weird limitation. Okay, let's go back to having this. And again, like once we finish with this whole pattern, like all of this stuff is going to be hidden anyway, so it's not going to be a big deal. All right, so same as with the others, we're going to need a delegation method. So let me grab run like this. So we're going to go over here and we're going to insert it like this. It needs to be netted one further like this. So we can use a lazy val over here. And the whole point of it is that it's going to demand a controller over here, right? And it's simply going to say zio.accessm, right? We're already familiar with this thing, right? So we're going to do get run. Now, this is a little bit heavy. And again, I would like to remind you that for now, we're not using this method and we're not using, where is it? In Google, like this one, right? It's going to be very, very important once we're going to start talking about effect tracking. All right, so now let's go and finally try to use it. Okay, so we have our dependency graph, and now what we want to construct is not the business logic.service. What we want to construct is the controller.service. Okay, so this is going to be controller, right? Let's fix the old one first. Like this is the one that we're not using anyway. Okay, so we're going to go over here. We're going to grab the console.make, and we're also going to construct the controller, right? Controller.make, and over here we're going to do BL and CON. And by the way, I probably should, like, because I'm using the C for the controller, I want it to be a little bit less confusing. So let's do over here same thing over here and over here and over here. Okay, so con is going to be console and C is going to be the controller. Okay, so we're creating the controller and we're returning the controller. Okay, and the same thing we're going to do over here. We're going to do controller service. Okay, and we're going to do a very similar thing. So we're going to get the console out of console.console.live, and we're going to get the C out of controller.controller.live.provide, and what's up with that? Okay, provide. So now we can wrap the business logic into a has, and now we can provide both. Okay, so let's save the file, and we need to return C, the same as we're doing over here, and now we can go and try to use it. In fact, well, at this point we can pretty much throw everything out, right? We don't need to assemble anything anymore. So we're still going to have a lazy val program. We probably don't even need the type. Okay, so we can grab the, let me scroll up a little bit. Man, I really want to see the dependency graph. Let's do it like this. Okay, so we're going to grab the dependency graph and we're going to do live, right? And it's going to give us a zio of something. Okay, so we're going to do flat map, right? And we're going to simply call run, not this run, but it is this run, okay, or technically this run. Okay, so there we go. We're going to save this. So this is now a zio any nothing unit, and if we open the console like this, everything still works exactly the same. Okay, now there's also another way to run this, right? To construct this this whole application is by doing dependency graph.live, and then we're going to do flat map, right? And now we can try to use this run over here, right? So we can do R, which is going to be our service. So we're going to controller.run, and then we can provide, right? R is our service, so we need to wrap it into a has like this. Okay, so this is going to assemble exactly the same application, right? It's still zio any nothing unit. And now if you stare at this for a very long time, you're also going to realize that we simply can do controller.run, right? And then we can simply provide has of dependency graph .make, right? So I'm really glad that we kept around, the old way to assemble the dependency graph. It's not going to stay with us for a longer amount of time. We're going to get rid of it very, very soon, right? But in the end, this is exactly the same program, zio any nothing unit. All right, so as you can see, has is still sticking out, and it is sticking out at the points where we assemble the dependency graph. So what we're going to do next is we're going to go to our live functions, and we're going to make sure that they already return a has, and this way we're not going to need to rewrap it, right? So again, we're moving everything to the declaration side, the whole boilerplate, so that we kind of have to do it once, and then at all call sites we don't have to repeat ourselves. Let's start by going to console, and we have live over here. So as you can see, it returns a service. Well, it should return console right away. We're simply going to wrap this into a has, right? Very, very convenient. Let's go and do the same thing over here, right? So we're going to start from the top. So this is going to be a business logic that doesn't produce a service. It actually produces a business logic. Okay, and how is it going to do this? Well, it's simply going to wrap this thing into a has for us. The same thing with the others over here, right? So it's like this, just gonna wrap make into a has. Same thing with the controller over here, controller. All right, so I'm gonna wrap this thing into a has like this. Okay, so now in our for comprehension, which is over here, we don't need to rewrap stuff, right? It already returns hases for us, right? So BL and over here, CON. Okay, let's see if I did everything correctly. Now we're obviously returning the controller and not the service, like this. There we go. Let's scroll down and look at the main real quick. This means that if we were to switch to the old one, like this one, we would just need to do R like this, right? Now, technically, like this would be ADA expansion, and a couple of videos ago, I mentioned that it got improved in Scala 3, where you can pass in a by name method to a place that requires a function that does not want a by name parameter, but somehow it doesn't always work. So if I try to comment this out, and I'm simply going to do this, right, controller write provide, then it's going to bark at me somehow. I don't know. I thought exactly this got improved, but somehow it's still limited. Okay, so let me enable this one again to show that it still works, and let me also show you this one, because over here now we need to, to get our service out of the has. Okay, but this is still my favorite, so for now let's keep using this one like this. Okay, so again, it is still a zero any nothing unit. One tiny thing that I would like to change before we continue, if we go to our dependency graph, notice how we're constructing everything one by one, like classical, like very sequential, very monadic way. However, we actually can create a couple of things sort of like in parallel. They don't depend on each other. For example, Google doesn't want anything and console doesn't want anything, so we can sort of create them side by side. Okay, so for example, over here we could go, and it's going to be very, very silly, and you're going to be like, why are we doing this? But it's going to become a little bit more evident a bit later. Okay, so we can construct, for example, a tuple over here by doing console.console.make, right? It's just going to be like a little bit more evident that they don't have any dependencies between each other, right? So we're constructing a tuple and we're deconstructing it right away on the left. And we need to do the same thing. Well, we don't need to, but I really want to do the same thing on the left over here. So we would need to do gcon like this. And over here, we would need to take two zeros and zip them together, right? So in cats, this would be called a product, right? You grab like two IOs together and you produce an IO that has a tuple of both of them, okay? So we're going to introduce this combinator in a second. Okay, so over here we're going to do console.console.live like this, and we can remove this. If I save the file right now, it's going to say that we don't have zip. Okay, so let's go and introduce it before we save the file. So where's our zero? Let's actually search for flat map. Okay, there we go. So I'm just going to introduce it right underneath the flat map. Okay, so it's going to be a zip. Okay, it's going to look very, very similar to a flat map, right? So we're going to have some sort of R, we're going to have some sort of E1, E1, and we're going to have some sort of B, right? So now we're not going to get a function. We're simply going to get this other has. In fact, I can just copy it like this. Okay, this other has. Okay, so now we're going to produce a zero that has R1, R1, E1, and now it produces a tuple. Okay, how are we going to do this? First, we're going to do this sequentially. Okay, so we're going to have a 4, and in the end, we're going to yield, the tuple was A and B. The A is we're going to get it out from this, and the B is we're going to get it out from that. Okay, so this is already the zip, and a little typo over here. This should be E1. There we go. Okay, so this is already zip, and therefore we can save this file over here, and everything is still going to work like a charm. Now, zip is a classic example of an applicative functor. In other words, it can be very, very safely parallelized, right? So libraries like CatsEffect and Zio, they always come with a version of zip and zip part that does this thing in parallel. Now, even though Zio is a concurrency library, ironically, we're actually not going to spend any time talking about concurrency in this entire series, because I'm convinced that the reader part of Zio is the most complicated one. So once you understand that, the rest is very simple. However, I also cannot completely avoid talking about it. So let me spend just a couple of seconds talking about concurrencies in Zio. Now, Zio implements an abstraction called fibers. If you're not familiar with fibers, you can think about them exactly the same way as you would think about threads, right? So you can fork a computation, you can join it back later. Obviously, this is functional programming. Nothing is actually being forked or joined. This is just the descriptions, right? So this is just like semantical blocking behind the scenes. No actual thread is being blocked. There's obviously a thread pool, and your computations are getting scheduled on that thread pool, and so on and so on. But just in terms of a metaphor, you actually can think of fibers exactly as you would think about threads, right? You fork stuff and you join stuff. So as of right now, like if this was the real zipPar would look exactly like this. So I'm just gonna grab this, right? I'm gonna do zipPar, right? The signature is gonna look exactly the same, which is exactly why we needed different names, so that because overloading otherwise wouldn't really work. And the implementation would be very, very simple. So instead of just wrapping A and B out of this, you're gonna wrap them from this fiber, right? And then you're gonna join it, the computation together, right? This fiber.join, and you're gonna compute the tuple of A and B. Now, where does this fiber come from? Well, it needs to be forked from the current computation at some point, okay? So you're going to produce this fiber by doing this dot fork, right? And then you're going to do that fiber by doing that dot fork. So very similar as how you would do this thing with the threads, right? You fork at some point and you join later. And in between, you can do whatever you want, right? Like this, right? Like, I don't know, like console dot, put string line or whatever, right? We don't have the real ZIO anyway, right? And in fact, in ZIO, there are so many very powerful abstractions. The same thing in Cat's effect, they're built on top of fibers. So chances are that you're never going to actually directly interact with fibers, right? Like zipPar, for example, a very powerful combinator. You just need to know that behind the scenes, there's some parallelism happening. In fact, once we're going to start rewriting our to-do app from tagless final into ZIO, there will be one place where zipPar is going to become very, very important, and we're going to talk about it. For now, let me just remove it and go back to our example. All right, so now our live functions, they always produce a has, like for example, over here. All we need to do now is we need to get rid of this ugliness, right? We need to go back to something like ZIO dot from function and then just pass in make, and it should do like all of this stuff behind the scenes for us. And this is where we're gonna introduce an abstraction called ZLayers. Now, ZLayers are simply wrappers around ZIO, and they do two parts, right? So basically, whenever you use ZLayers, they assume that you're gonna have the has in the reader and some other has in the success channel, right? So if you read the documentation about ZIO, they will say, okay, like ZLayer is something that transforms, one service into another one, right? But it's just a wrapper around ZIO. Like technically, it's almost like a monad transformer. We're gonna get to that in a second. Now, as a first step of introducing ZLayers, we're actually not gonna introduce them as a layer. We're simply gonna have an object ZLayer. We're gonna have a couple of functions inside of them, and they will simply return ZIO back, right? So we're actually not gonna wrap anything yet. So let's go to our ZIO. And by the way, I have the entire code of this whole thing ready for you. Just check the link in the description. And over there, I cleaned everything up, and not the whole thing is in one file, right? So there's a file for has, there's a file for ZLayer, and so on and so on. Just check the link down in the description. Okay, so we're just gonna go to the bottom of our file, and we're going to introduce an object called ZLayer, like this. Okay, so over here, we're gonna succeed, and we need to wrap things into has, right? Like this is the whole point. Like this thing is going to hide has from us. This is one of the reasons for existence of ZLayers. Okay, so we're going to succeed with some A, so we need a class tag so that we can wrap whatever comes out into a has. Okay, so we're going to receive an A. Like this is very, very similar to succeed from ZIO. Okay, so we're going to succeed with ZIO any nothing has A, right? Technically, like in the real ZIO, again, like there would be a helper that would help you distinguish between any and has any, or technically would actually remove this distinction, but we don't need it, right? So this is fine for us. The implementation is very simple. We're simply going to ZIO succeed, right, with an A, right? This would be like the regular succeed, but the whole point of this would be to wrap this thing into a has, okay, like this. Okay, we can actually already go and use it. So for example, we can use it in our console. Where is it? Console over here, for example, right? So over here we can just do ZLayer, right? And now we don't need to do has make. We can just do make, right? Let's actually go and use it in the other places as well. Okay, so let's see. No, over here, for example, right? So we can do ZLayer, and it will wrap the has for us like this. Is this the last one? Yeah, this is the last one where we can just use succeed. Okay, so now remember in the regular ZIO we have this thing called from function. This is the one that we have been using all along. Okay, so now on ZLayers we're going to call it from service, right? Because it's going to take a has, it's going to rip out the service, and it's going to call from function for us. Okay, so let's go down. It's going to be very similar. In fact, let me actually Let me actually copy from function. I'm going to insert it somewhere over here so that you can kind of like look at it. Okay, cool. So we're going to do from service. And in the real ZIO, you have a bunch of overloads, right? So you have from service, which wants which wants one thing. Then you're going to have from services that is going to want two things, and it's overloaded with like 3 and 4 and 5 things. In our case, we're only going up to 2. Okay. So for example, over here from function, we're ripping out 2 things, and there's also another place where we use from function over here where we're ripping out only 1 thing. Okay. So it's going to be from service and from services. If it was up to me, if I was the one creating ZIO, I would actually call all of them from services, even the one that receives only 1 argument, just so that I can minimize the diffs. All right, so we're going to do from service, and we're going to start with some R, and we're going to make sure that it is some sort of has with a service. Okay, so we're going to make sure that as actually has a class tag, and we're also going to make sure that a also has a class tag. Okay, so now we're going to have a parameter, which is going to be a function, right, that is going from as to a, right, so from our service to our a somehow, and this whole thing is going to produce a ZIO of R, nothing, and it's going to wrap the has into an a. Okay, so we need the class tag for the as because we need to get the service from the has, right? So we need the class tag for that, and we need the class tag for a so that we can wrap it into a has when we're coming out. Okay, the implementation is super simple, right? We're just going to do ZIO dot from function. Right, it's literally this thing. Okay, in fact, I can just grab this thing, right? I can just go do this, right? ZIO from function. Okay, so we're going to have some sort of environment, right? So this is going to be our has. Okay, we're going to get it out. I'm going to rename this one to R. So we're going to get it out. We need to get out the as. This is why we needed the class tag. Okay, so now this is going to be our service, and we need to get the a out, right? How we're going to do this? Well, we're going to stick the service into the app. Okay, so now we have our a, and then we just need to return the has of a. Okay, like this. This is the whole implementation, and obviously let's go and indent this whole thing. So this is going to be an f of service like this, right? Like that, and we're using this thing only once as well. So we're going to do this. So we're going to do that, JJ, like this. Okay, and again, like this is the thing. This is like the only place where you can like leave it out because like over here it's gonna be able to figure it out. I'm gonna leave it for you guys. But when we're gonna use from services, we're gonna get like S1 and S2, and over there we're gonna be forced to specify the type. Okay, so let me actually go and copy this. Paste it over here. I'm going to call it from services, and I'm going to use metals to rename this as into S1. Okay, so this is going to be S1. So our R is going to have has S1, and it's going to have a has S2. And we're going to need the class tags for both of them. Class tag like this, okay? And this is the thing, like this is just going to be a function that wants both things, right? Which is also the reason why we can live with only one implementation of from function. However, with from service, we need a bunch of overloads. Okay, so we have the R, we have S1, we have S2, we have like both of them are coming in. So we're producing an R nothing and has a. So we're going to do from has function. We're getting the first one, and then comma R dot get, and we're getting the second one. Again, for some reason, like for the first one, you can leave out the type, right? For the second one you cannot. Okay, so we need to keep using it. Okay, so we have from service and from services, and so ZLayers, they hide has for us even better. So now we can go back to main and look at this ugliness, and instead of this whole thing, we're going to do ZIO dot from service, right? So it wants only one service, and we can just pass it make, and it will do like this whole nonsense for us. Okay, I'm sorry, it needs to be ZLayer. Right? But for now, at least it returns a ZIO right away. Let's scroll down to this one. Like this one is going to benefit the most. Okay, so this is going to be ZLayer from services because it's 2 of them, and now we can just pass in make, right? Which is a function that wants 2 things, right? So all of this stuff just goes bye-bye. All right, so let's introduce the proper ZLayers. We're going to diverge a little bit from the real ZIO, but no worries, we're going to bring it back real quick. So we're going to add like a couple of, so it's going to be just a wrapper around ZIO. We're going to add a bunch of delegation methods, and the real ZIO doesn't have a couple of them, but it's going to be more convenient for us to implement some stuff. As always, in the beginning, it's going to be uglier than what we currently have, but in the end, we're going to rip the benefits from it. All right, so if we actually scroll to the top of the file, we're going to have our ZIO, we're going to copy it, we're going to go down, and we're going to go and insert it over here. This is going to be a final class ZLayer, and it has exactly the same parameters, and inside of it over here, it's going to just have the ZIO, right? It's going to have the ZIO with the REA, right? Just a wrapper. Nothing fancy. By the way, technically it's unnecessary. It's sort of like a stylistic choice that they made in ZIO that ZLayer is an actual, an actual wrapper. And by the way, this stuff is going to be improved in ZIO 2. I don't really know how. Like for now, ZLayer has a lot of like helper methods, the same as the regular ZIO has. Apparently, it's going to be slimmed down a little bit. It shouldn't change too much though. All right, so now pretty much everywhere where we return stuff, which is over here, we're going to return ZLayer. And how we're going to do this? Well, every time where we say ZIO dot, we're simply going to wrap this whole thing into ZLayer, right? So now everything is like wrapped into ZLayers. Okay, so now we need to go up and we need to, because we were so diligent with our types over here, now this thing actually returns a ZLayer. Let's save this. Nothing is going to compile in the main method. Okay, same thing over here. The type changes, right? So this is the ZLayer. Now this over here is also a ZLayer. Okay. Now over here, it's also a ZLayer, like this. And now we need to fix it in the for comprehension. Again, in the beginning, we're going to make it uglier, right? So we're just going to rip out the ZIO. We're going to rip out the ZIO, right? So every time, pretty much every time where we say live, we're going to rip out the ZIO like this, okay? And in the end, it's going to stay a ZIO. As the next step, we're going to create a bunch of delegation methods that I'm actually going to copy because there's nothing fancy or important about them. Right, so we're going to have a column over here, enter over here, and we're going to insert them over here, right? So a bunch of delegations, right? So flat map, zip, map, provide, some provide, they all just delegate to, to the underlying ZIO, right? And this allows us to go over here and remove all of these .zios that we just introduced, like this, right? But now this whole thing produces a ZLayer. And so at the very, very bottom, like every time we do run, well, technically in this one, like this one can still stay the same, right? But if we were using like this one, like at the very last step, we will simply rip out the ZIO, or over here, same thing, right? We would rip out the ZIO like this. Okay, but let's not use them for a while. Let's do this. Let's do that. In fact, if you were to look at this one, like any implementation that, like any version of this that we take still has issues. Like for example, this one is still wrap stuff into a has, but I thought we just introduced ZLayers that do exactly this for us. Okay, and if we were to go back to like these ones, they rip out the ZIO from the ZLayer. Now this clearly smells like a combinator. So we're going to introduce a combinator that is going to do essentially this thing for us, and it's going to be inside of ZIO, and it's going to be called provide layer. And once you provide the layer, it rips out the ZIO for you. So let's go to our ZIO. Let's actually find provide. Remember we have like this stuff where we have like provide custom layer, and I told you once we talk about layers, this will actually return the ZLayer, and provide custom is not going to exist, but we're going to do this a bit later. So let's just go and add it like over here. Okay, so it's going to be provide layer. The current implementation that we're going to have is not going to be final, but it's going to be enough for us. Okay, so it's going to have some sort of R1, E1 was an E. Okay, so I'm going to give it a layer, right? ZLayer R1, E1, and R, and it's going to return us a ZIO of R1, E1, A, right? And the implementation, we can pretty much copy it from here. It's going to be over here. Okay, so we're going to have some sort of layer, right, over here. We're going to rip out the ZIO, we're going to do flat map, we're going to do R, and now we're going to have, like, we're inside of ZIO, so we're just going to provide the R like this. Okay, so this is the implementation, very, very simple, like this. And what's up with this? I made the same typo. What is happening? There we go, R1, E1 provide. And again, I wish that we were able to just do this, right? But somehow this limitation is only lifted in some corners of Scala, I guess. Okay, so now that we have this, we can actually go back over here, and instead of provide, we can simply provide layer, right? We can remove the has, and we can do this, and now we can actually switch to live. Okay, so now we're providing the live layer, and this is also pretty much the point where we stop using make, right? We don't need to use make anymore. I'm going to comment it out for now, but we can pretty much throw it out. Okay, so this is like almost like the final version of how you would actually construct your ZIO programs, right? You're going to have some sort of ZIO. You're going to have some sort of layer. You're going to provide this layer to your ZIO. In fact, now that we have provide layer, we can actually go to our ZIO environment. We're going to realize that ZIO environment is actually, and by the way, we could have been using a type alias for a very long time over here, right? So the ZO environment is actually a layer in its own right. So we're going to have an object over here, ZENV, and it's going to have live, lazy val live, which is going to be a ZLayer that doesn't want anything, producing nothing, and ZO environment, right? And so it's going to be like console.live, and like in the real ZO, this would be like also like plus, you know, that would be like, you know, clock.live and so on. Okay, but for now it's just a console. Okay, and now in the runtime, which is right above over here, where we're still doing has and console.make and stuff, we're simply going to do ZO.provide layer, right? We can do ZO environment live, right? And now that everything is provided, we're simply going to run it. Okay, so now we don't need to deal with has. Like has is now completely hidden. This is probably where I should wrap this video up, and we're going to continue in the next one, and we're going to learn about an awesome DSL that is defined on ZLayers, and also we're going to talk about effect tracking, which is going to be very, very important. I hope you enjoyed this video and also the previous videos in this series. I'm going to see you in the next one. For now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on GitHub sponsors or Patreon, whatever you prefer, and also watch my videos weeks and sometimes even months before everyone else, including this series, which is probably over by now. In any case, most importantly, take care.